Hello, guys, and welcome back to the next part of my matter unit series. And in this video, I'll be going over phase changes and states of matter. Okay, so we have three states of matter that we know of: liquid, solid, and gas. And assuming you're either an 11th or 10th grader, you should all know what all of these mean by now, I hope. So a solid is something that has a definite shape and a definite volume. So here we have it's like really organized. It's just square. It's 4 by 4, definite shape, definite volume. It'll always maintain its shape. It'll always have the same amount. It'll always take up the same amount of space. And in an equation, a chemical equation, you would put an S in parentheses next to the compound or element. So that's a solid. So a liquid is something that has no definite shape, but it does have definite volume, meaning its shape will change, but it will take the shape of its container. However, it will always take up the same amount of space. It'll never take up more space. It'll never take up less space. And here you can see they're not as compact as in a solid, but they're still pretty close together. But they're no arrangement. Like it's just like kind of this weird blob. And also in an equation, you'd put a parentheses L next to the compound to indicate that it's a liquid. Finally, we have a gas. So a gas has no definite shape and no definite volume, meaning that it never stays the same shape, and it will never take up the same amount of space. And here you can see that they're all really far apart and they're going everywhere. You know how gas works, like water vapor. You got water, ice, and then water vapor. In an equation, you'd put a parentheses G, so carbon dioxide gas. Aqueous is something you would need to know. Basically, it just means something that was dissolved in water, and you just put parentheses AQ next to it to indicate that not a solid, but aqueous. I don't know why it says solid. Oh, they all say solid. Solid. So it says it's supposed to be would indicate liquid, would indicate gas, would indicate aqueous. Okay. Anyways, all aqueous substances are homogeneous mixtures or solutions, which we learned about in the compound video. So here we have the phase changes. So you can see that we got solid, liquid, gas. So, okay, yeah. So first we'll start with melting. Melting is going from a solid to a liquid. And in order to get from the solid to the liquid, the compound or substance would have to absorb energy, meaning like take in heat to change from the solid to the liquid. So the most notable example is when ice melts and turns into water. And vice versa, we got freezing, which is just like liquid to solid again, which would be means that the substance would have to release energy or release heat. And that would just be like water to ice. Then we got boiling, or you probably will see it as vaporization. So this is when a liquid goes to a gas, and the substance has to absorb energy to do this. So it'd be like water to water vapor, and you'd see this when you'd put a kettle of water on like a stove, and then the kettle whistles that weird annoying sound, and you see all like the steam coming out of it. That's water vapor. That's the phase change. And then the last three would be condensation, which is the opposite of vaporization. The gas particles come together back to form liquid again, and basically the substance would have to release energy in order to do that. So gas to liquid. That's condensation. Well, I'm trying to see what this. I don't remember this graphic. I don't know what this is, honestly. I forgot why I put this there. Anyways, um, sublimation is the act of a solid going straight to gas form, skipping liquid. That it has to absorb energy to do this, and a notable example of this would be dry ice. Like if you hold dry ice and you can't hold it because that would burn your hand. But like you see, dry ice releases off this like gas, like this smoke. That's sublimation. And finally, we've got deposition, which is the opposite of sublimation. The substance needs to release energy in order to do this. It goes from a gas to solid. So there's also these two things, the heating and cooling curves, which you'll need to know about. Basically, you see that at 0 degrees Celsius, there's no change in temperature, meaning that solid and liquid are equal there. And at 100 degrees Celsius, it's the same for liquid to gas. And as you go up in temperature, it changes from a solid to this phase, the melting phase. Then it goes to the liquid phase, to the vaporization phase, then to the gas phase. And in order to go up, energy must be absorbed or temperature increased. And then the exact opposite of that is the cooling curve, which is basically the same thing, except the gas goes to condensation to liquid to freezing to solid. And guess what? In order to do this, you need to release energy. And I think that is it on this. Yeah. I did forget to mention though that it does take more energy to boil than to melt, because you are completely breaking the attractions between the particles. Because if you like look at this, when you go to a solid to a liquid, the attractions are only broken so little. Like it's still, there may not be a definite shape, but you still have like the definite volume. But when you go from the liquid to the gas, you break the attraction completely. That takes so much more energy, because then it goes from like this very there's like more, the atoms have more attraction than this when they actually push each other away. I hope this helped you a little. I will post about this in the future, but I probably will not get through the rest of the chemistry course before the Regents, which was my goal, but I did not take into account how busy I would be with exams and stuff. So I'm going to probably post as much as I can before then, and I will definitely post a 20-minute Regents chemistry crash course video where I'll just go like, or a cram video where I'll just like have everything very basically summarized in 20 minutes, and I'll post that before the Regents. But I'm definitely planning on that. I'm not sure about the rest of the course. I'll probably finish that in the summer or something. I don't know. But anyways, thank you for watching, and I hope you enjoyed the video and it helped a little.